Welcome back. In this video, we're going to talk about artificial intelligence for our enemy. We're going to make some really basic AI. All we're going to do is make the enemy chase the character. Let's get started. Now we have here the character and the enemy, and they both have their own screen space locations. The upper left corner of the screen is 0, 0 in screen space. Now, in order for the enemy to chase the character, the enemy needs to know which direction to move in. Now, the first step in getting that direction is finding the vector from the enemy to the character. Let's call this vector B. Now, the enemy's location in screen space is the vector from the origin, or upper left corner, to the enemy. Let's call this vector A. And the character's location is the vector from the origin to the character. Let's call this vector C. Now we've already seen that with vector addition, A plus B is equal to the vector C. Now B is the vector we're after. I'll go ahead and spare you the headache of solving this equation for B. Here it is. B is equal to C minus A. And this is a very important formula for getting a vector from one object to another. In general, the vector from a source location to a destination location is equal to the position vector of the destination minus the position vector of the source location. So we can call this vector from the enemy to the character to target because it's from the enemy to the target. So each frame, we're going to need to get this vector. The next step is we need to normalize this vector. The reason is because the distance from the enemy to the character will change each frame, and we just need a vector with a consistent length pointed in the correct direction. So the vector from the enemy to the character normalized will have a length of 1. The next step is to scale this vector by multiplying it by the enemy's speed. This will give us a vector from the enemy to the character with a length of speed. Then all that's left to do is to move the enemy towards the character by adding this vector quantity to its world location. Now we're doing this every frame because the relative positions of the character and the enemy will change from frame to frame. So as the character moves relative to the enemy, each frame the enemy will get this vector and make these calculations in order to move closer to the character. So we know the main steps we need to perform in order to make this AI behavior. When we write them out like this in relatively normal human language, we call this pseudocode. Pseudocode helps us to write out a roadmap of where we want to go in our code. As a challenge, you're going to write pseudocode for this code we want to put in the enemy tick function, and you're going to use comments to do it. Using single-line comments, write out the steps we need to take in the tick function. First, we need to get the toTarget vector. Next, we need to normalize this vector. Next, we need to multiply it by speed. And finally, we need to move the enemy, in other words, set the world pause vector. Put these comments at the top of the tick function before anything else. When you're finished, share your results in the discussion and see what other students have come up with. Pause the video and do this now. So here we are in the enemy's tick function. And at the top of the function, before we do anything else, we're going to write our pseudocode. Now, our first step is to get the toTarget vector. So we're going to say get toTarget. Next, we need to normalize toTarget so it has a length of 1. After this, we need to multiply toTarget by speed. And finally, we need to move the enemy toward the character. So now that we have our pseudocode, let's go ahead and program this. We'll start with our first step, get toTarget. Now we need to perform subtraction, so we're going to use vector2subtract. And we know that to get the vector from the enemy to the character, we need to subtract the character's screen position minus the enemy's screen position. Now we have access to the character. We have its address stored in a pointer called target. And we know that we can access members and methods on target using the arrow operator. But because we're not on the character itself, we can only access public members and methods since we're attempting to access them from outside of the character class. This means that in order to get screen pause, we need a public getter. Let's add this public getter to the character class. So here in the public section, we'll make a function that returns a vector2 called getScreenPause. And it's simply going to return the value of the screenPause variable. Now from within the enemy class, we can access the public function getScreenPause on the character class. Now we need to subtract the enemy's screen pause, and since we're acting from within the enemy class, we can access that protected variable. So this function will return a vector that is the result of the character's screen pause minus the enemy's screen pause. Let's store this in a local vector2, and we'll call this toTarget. So now we have toTarget, and our next step is to normalize it. So we're going to use vector2normalize. And this function takes a vector2. We're going to pass in toTarget. Now, vector2normalize does not actually change the variable toTarget. It simply uses it in its calculation and then returns the result as a vector2. So we can store that, and we're going to store it in the toTarget variable. So the value that was in here before will now get overwritten by the result of this vector2normalize. Our next step is to multiply toTarget by speed, and we're going to use vector2scale. The first parameter is a vector. We're going to pass in toTarget. And the second is a float variable, and we're going to pass in our speed. Since toTarget is a normalized vector now, multiplying it by speed results in a vector with a length of speed. Again, we're going to store this in toTarget, writing over its value again. So now we have a vector pointing from the enemy to the character with a length of speed. All that's left is to move the enemy, and that involves setting its world pause vector. And we're going to set it equal to the result of a vector addition. So we'll use vector2add, and we're adding the enemy's world pause plus toTarget. And now we've changed the enemy's world pause, moving the enemy closer to the character. Now, since we've changed world pause, the next step that we do is change screen pause by adjusting it using the character's world pause vector. And then we call tick, which will actually draw the enemy. Now, before we test this out, notice that we're using speed, and speed is initialized in base character. Remember, we gave it a value of 4.f, which means our character moves at a speed of 4. And if the enemy moves at the same speed, it might not be so fun. So let's give the enemy a slower speed. We can do this by assigning speed in the enemy's constructor. Let's give it a value of 3.5f. And now we can hit run and start debugging. And here's our enemy. It's chasing the character, and it's not quite as fast, so the character actually has a chance of getting away. Great job. So in summary, we created some basic enemy AI, and now our enemy chases the character. Very nice. We'll see you in the next video.